Hello dear friends, once again welcome back to my channel Scientific Phenomenal Facts। आज मैं नया साल जो शुरू होने वाला है उसका पहले ही मैं आप लोगों को एक गिफ्ट दे रहा हूं जो नया साल का तोहफा है। यह मेनली हायर सेकेंडरी जो फाइनल ईयर का स्टूडेंट है उन लोगों के लिए बहुत बड़ा एक गिफ्ट है। ये एल्डोल कंडेंसेशन में आप लोगों को सिखाने वाला हूं कि एल्डोल कंडेंसेशन क्या है। तो चलिए हम लोग देखते हैं कि एल्डोल कंडेंसेशन क्या है, एल्डोल का मतलब क्या है। एल्डोल कंडेंसेशन में एल्डिहाइड और कीटोन में एटलीस्ट एक अल्फा हाइड्रोजन एटम होना जरूरी है। तो अल्फा हाइड्रोजन का ही भूमिका होता है इस एल्डोल कंडेंसेशन में मेनली। बगैर अल्फा हाइड्रोजन के यह हो ही नहीं सकता। और अल्फा हाइड्रोजन क्या है यह हम लोग सीखेंगे थॉरोली, स्टेप वाइज हम लोग चलते ही सीख जाएंगे। उसके बाद अल्फा कार्बन, बीटा कार्बन, कार्बोनाइल कार्बन, यह हम लोग सब इस टॉपिक में सीखने को मिलेगा हम सभी को। तो एल्डिहाइड्स एंड कीटोन्स containing at least one alpha hydrogen atom, when treated with dilute base like sodium hydroxide, potassium hydroxide, etc., undergo condensation to form aldol. चलिए इस एल्डोल कंडेंसेशन में ये एल होता है एल्डिहाइड और ये ऑल होता है अल्कोहल। क्या ये माजरा समझ में आया क्यों इसको एल्डोल कंडेंसेशन बोला जाता है? क्योंकि इस एल्डोल में दो वर्ड्स एग्जिस्ट होता है एट अ टाइम, जो एल्डिहाइड का और अल्कोहल का कॉम्बिनेशन का फॉर्म में होता है। इन एल्डोल कंडेंसेशन एल्डिहाइड एंड कीटोन्स containing at least one alpha hydrogen ओके नो। एल्डोल कंडेंसेशन में एल्डिहाइड्स और कीटोन्स के पास कम से कम एक अल्फा हाइड्रोजन होना होगा, अल्फा हाइड्रोजन एटम। When treated with dilute base like sodium hydroxide, barium hydroxide, etc. Undergo condensation to give aldol or to form aldol. Okay. This reaction is called Aldol condensation. Okay, now here aldehyde and ketones containing at least one alpha hydrogen atom when treated with dilute base like sodium hydroxide, potassium hydroxide, potassium carbonate, barium hydroxide, etc. Then it undergoes condensation to form aldol. Already I have informed you that aldol is the mingling of two different functional groups, okay, at a time. That's why it is considered as aldol. For this aldol condensation, let us see one example. Okay, come let's see. For example, two molecules of acetaldehyde combine with each other. In the presence of dilute sodium hydroxide to form 3-hydroxyl butanol. Here, for example, two molecules of acetaldehyde, when they combine with each other in the presence of the dilute base like sodium hydroxide, it forms 3-hydroxyl butanol. Here, hydroxyl group is there together with here aldehyde group is there. One is OH group, another one is C double bond O. The reaction becomes CH3, here single bond, here carbon, here this one aldehyde group, functional group, this one hydrogen. This one is acetaldehyde. When another acetaldehyde, CH2 we are writing. Why? Here we are going to write the alpha hydrogen. Okay. Here the game of this alpha hydrogen. Same molecular formula. Only here we are writing the alpha hydrogen in the single bond form. Then it forms when they react with base. Here hydroxyl group or sodium hydroxide. Here hydroxide is a base, no. Here this negative charge we are writing above this oxygen because hydrogen always electropositive. So either we can write here also, no problem, because this one is radical, no. So it forms CH3 here, single bond, carbon, this hydrogen will come here, CH, then here single bond, OH, bonded with this CH2, a single bond, carbon, here carbonyl carbon, then this hydrogen. Here our intention is to find out this 3-hydroxyl butanol. 1, 2, 3. 3-hydroxyl methane, ethane, propane, butane. So butanol, here double bond. Okay, so butanol. This is a functional group. Here our intention is to find out this one. So thoroughly I am going to show you how is the mechanism stepwise. Let us see. Here one more thing. This one is carbonyl carbon. Okay. This one is here alpha carbon. The first carbon after the carbonyl carbon, the first carbon is alpha carbon. And the second carbon is the beta carbon. So it means first, second, third. Third carbon after in the third position, the carbon from the carbonyl carbon, the third carbon is the beta carbon. And the second carbon from the carbonyl carbon is the alpha carbon. That thing we have to keep it in our mind. And here we have come through this alpha hydrogen. What is the meaning of alpha hydrogen? Can you tell me? Here, alpha hydrogen, it is highly acidic in nature. That's why it is readily reacts with the dilute base. That's why it is known as alpha hydrogen. So it's clear now why alpha hydrogen is acidic. Because here the matter of base is coming. So without acidic medium, how the base can be reacted or can be broken? That's why here the matter of alpha hydrogen arises. In case of Aldol condensation. So the matter of alpha hydrogen is clear to you. The matter of alpha carbon, beta carbon as well as carbonyl carbon. This one is carbonyl carbon because the aldehyde group, the aldehyde functional group, carbon is carbonyl carbon. And here hydroxyl group, this one is hydroxyl, no? Here this one is hydroxyl. It is alcohol and this one aldehyde. Both group exist at a time in a single molecule, in a single compound. That's why it is termed as aldol. And it gets condensed. That's why it is aldol condensation. Now let us see the mechanism thoroughly. अभी हम लोग देखेंगे इसका mechanism पूरा step wise. क्या होता है अल्फा हाइड्रोजन का माजरा और अल्फा कार्बन, बीटा कार्बन, इन लोगों का क्या रोल है? तो चलिए हम लोग देखते हैं इस मैकेनिज्म को थॉरली. लेकिन हमारा जो इंटेंशन है ये यही निकलेगा जो 3 hydroxyl methane, ethane, propane, butane. So butanol. Clear now? So the point you have to remember that it's the alpha hydrogen that is added to the aldehyde. Okay, no? So I had the matter of 1, 2, 3, 4. This game also you have understood. It is based on the alkane series. Clear? Come, let's see. Now let's see the mechanism. The reaction is reversible. And involves the following step. Here the reaction, that is aldol condensation, it is reversible. First step. In this first step, the anolate ion is formed. How, let us see. Here let us write CH2. Here this one is the alpha hydrogen, because this one is acidic in nature. We have taken acetaldehyde. Already we have written in our approaching. This one functional group of aldehyde. When reacts with base, here sodium or potassium or barium, I am not writing that one. Here the main function is of the base. This reaction is reversible. Already I have informed you. This one is negative. No. Here this oxygen, it has one electron excess, that's why it is negative. Here this alpha hydrogen, it gets attracted by the base. Okay. And then this becomes water. Remaining what? Here hydrogen reacts with this base, it becomes water. Then here one electron of this carbon, it is bonded to one electron of this hydrogen. It is no. When this hydrogen will react with this hydroxyl group, it becomes water. Remaining only this. This one electron will move towards this carbon. Carbon, it has 1, 2, 3, 4 bonding. No. This electron of this carbon and these two hydrogen, it's also bonded to the two electrons of this carbon. And this carbon-carbon bonding is also there. But here, if this hydrogen moves towards that one, its bonding remain vacant. So one electron will shift here. It becomes CH2. Here C double bond O. Here H. Then what happens here? This one electron of this carbon is present. But the electron of this hydrogen, it is donated to this carbon, and here one more electron this carbon it has. That's why it becomes negative. Clear now? Here let you see. Oxygen, it has one electron excess, no? So it will share its one electron with one electron of this hydrogen. It will form water. And this bond, here one electron of carbon, it is bonded to one electron of this hydrogen. This one electron will donate to this carbon. So one electron excess here, so it becomes negative. That is known as anolate ion. Okay. Or we can say nucleophile. Or we can write nucleophile. Why it is nucleophile? Can you tell me? Here, let you see, nucleophile meaning nucleus lover. Nucleus lover, it means it lacks nucleus. And in my video of electrophilic addition reaction, already I have explained what is electrophile and what is nucleophile. Electrophile means electron lover or electron loving, which lacks electron. And nucleophile meaning it lacks nucleus. It needs nucleus, no. So it is nucleus loving, that is nucleophile. So this is our first step. Now, so the concept clear, no? This bond here broken, and this is the electron of this carbon, and this electron also came here. That's why it becomes analyte ion, or we can say nucleophile. Now let us see, come to the second step. In our second step, the analyte ion attacks the carbonyl carbon. Of another unionized aldehyde molecule. यह क्या होगा, जो एनोलाइट आयन है वो अटैक करेगा, किसको अटैक करेगा, जो दूसरा और एक अनआयनाइज्ड है, जो आयन नहीं बना है, उस एल्डिहाइड मॉलिक्यूल का कार्बोनाइल कार्बन को अटैक करेगा. तो चलिए हम लोग उसका रिएक्शन भी देख लेते हैं. CH3 C, a double bond O, and H. This one is the carbonyl carbon. Okay, no? When this analyte ion here, this analyte ion, this attacks the carbonyl carbon, and it will make bond with each other. Here, this analyte ion, as it is nucleus loving nucleophile, as it is nucleophile, no, that's why it is nucleus lover. So this analyte ion, it attacks the carbonyl carbon, okay, in order to get the nucleus, or you can say the bond formation. By virtue of which, what happened here, this carbon has one electron, other electron, here all are bonded to each other. When this carbon will make bond, let me show you. Already I have explained that all the reactions are reversible. Here what will happen? CH3, here this one electron and this hydrogen will attach carbon hydrogen. Here this oxygen is there. It will become negative. Then here this CH2, C double bond O, here hydrogen. How it happened, do you know? Here methyl group, here single bond, this carbon bonded to this carbon here, okay, this carbon. Now this carbon with its one electron, it gets bonded to one electron of this carbon. It is no. Here this electron and one electron of this carbon, it gets bonded. This one. And here one electron of this oxygen, it becomes excess. That's why it is negative. Clear, no? When this one electron of this carbon, it gets bonded to this one electron of this carbon. It makes single bond, and one electron of this oxygen, it becomes excess now, non-bonding. That's why it becomes negative. It's clear now? You see, 1, 2, 3, 4. 4 bonding this carbon need in order to stable. It got. But this oxygen need 1 and 2. 2 bonding to get stable. But here it got 1. So 1 electron excess, that's why minus. Here this one is delta plus. And this one is delta minus. This oxygen becomes delta minus and this one is delta plus. Clear now? Come now, let's see our third step. In our third step, the negative oxygen accepts a proton from water to give aldol. Okay, here let you see CH3 CH. Here this oxygen is negative, no? CH2. Here C double bond O. Here H. Here this negative oxygen, it will accept one proton. Here hydrogen, it is considered to be a proton. Do you know why? All of us know that hydrogen has isotopic property. Protium, deuterium, tritium. Here protium, it is 1H1, atomic number 1 and mass number 1. So it can be compared to the mass of a proton. That's why under acceptable case, this hydrogen is treated as proton. Clear now? So this negative oxygen, it will accept one proton from this water to give aldol. If it accepts one proton from proton, then one electron, this hydrogen has, if this oxygen, it is negative, no. If it accepts one proton from this water, then this hydrogen, it has one proton and one electron, is it no? So one proton accepted by this oxygen. Well, then what happened to one electron which is left by this hydrogen? It will release to this hydroxyl group and it becomes negative. So let us see. This one is also reversible. CH3 CH, here OH. This negative oxygen, it accepts this proton. It becomes hydroxide, or we can say alcohol group, hydroxyl group. Now CH2, here C double bond O, then H. It becomes carbonyl carbon. Okay, aldehyde group. This one aldehyde group, this one alcohol group. That's why it is called aldol. The mingling or the composition of the two different functional groups in a single compound. Here we got 1, 2, 3. Here 3 hydroxyl methane, ethane, propane, butane. Butanal. Clear? And this hydroxide, it remains here. Here one electron left by this hydrogen, so here one electron excess for this hydroxyl. It becomes negative. Option becomes negative. This one hydroxyl. This negative sign we can put here also above this hydrogen. But here all of us know that hydrogen is electropositive, whereas oxygen is electronegative. That's why we are putting here. So this one is our product, no? 3-methyl butanal. Or we can write aldol. It's our aldol. Clear? Here one more point. Here, aldols are easily dehydrated either by heating or by treatment with dilute acid to form alpha beta unsaturated aldehyde. तो इधर में हम लोग एक चीज जानते हैं कि एल्डोल्स को डिहाइड्रेटेड किया जाता है माना कि हीट द्वारा या उसको डाइल्यूट एसिड के साथ रिएक्शन करने के बाद। तो वो क्या फॉर्म करता है? अल्फा बीटा अनसैचुरेटेड एल्डिहाइड फॉर्म करता है। तो चलिए वो भी देख लेते हैं। लेकिन हम लोगों का जो मेन एल्डोल कंडेंसेशन है, ये इस हद तक हम लोग लिख सकते हैं। तो सभी जो विद्यार्थी है, जो स्टूडेंट है, उन लोगों के लिए इस हद तक काफी है। लेकिन जब आप लोग मेडिकल एंट्रेंस या आप लोग इंजीनियरिंग में जाएंगे तो उसमें और ज्यादा ब्रॉड कंसेप्ट होना जरूरी है। तो उसीलिए मेरा साथ बने रहिए। तो जैसे कि मैं बता चुका हूं कि एल्डोल्स आर इजीली डिहाइड्रेटेड either by heating or by treatment with dilute acid to form alpha beta unsaturated aldehyde. Come, let's see that one. CH3 CHOH CH. Here hydrogen we are writing in the bonding form with carbon here. Here this one 1, 2, 3, 3 hydroxyl. Butanal 1, 2, 3, 4. Methane, ethane, propane, butane. So butanal. Here with respect to aldehyde, its suffix will be al, nal. Here when it is heated, then what happens? Let us see. CH3 CH, here double bond formation, CH, here C double bond O, here H. Then this hydrogen and this hydroxyl group, it will share with each other and it will form water. Clear now? Here the name of this 1, 2. So 2 methane, ethane, propane, butane, butanal. Or we can write this one croton aldehyde. Okay now, this one 1, 2. Here the functional group appears So here 1, 2, 2 methane, ethane, propane, butane in a series wise butanal with respect to aldehyde functional group. Its other name is croton aldehyde. Already I have explained that this one is carbonyl carbon, then the second one is alpha carbon, third one is beta carbon. Clear? Here at the last alkyl group, these three are the three alpha hydrogens. So here any one we have taken in order to get the aldol. Clear? Since formaldehyde, trichloroacetaldehyde and benzaldehyde do not have alpha hydrogen, that's why they do not undergo aldol condensation. Okay, but here now I have already explained in the beginning that aldehydes and ketones. Here in case of ketones also aldol condensation is possible. What I am going to show you. Please be with me. Here ketones containing alpha hydrogen also undergo aldol condensation. To form ketols. Here it is ketols. Okay, in case of aldehyde it is aldol. In case of keton it is ketols. The mixture of the combination of keton and alcohol. Here also I am giving you one example. Let you see. For example, two molecules of acetone combine with each other. In the presence of barium hydroxide. To form 4-hydroxyl methyl 2-pentanone. Or we can write here diacetone alcohol. Or this one, its name is diacetone alcohol. Come, let's see. Here CH3, C double bond O, here CH3. When the two, here already I have explained two molecules of ketones. One molecule of ketone and here another. CH3, here C double bond O, here CH3. Here this and this both are ketone. Now when it reacts with, here where in the presence of barium hydroxide, no? Barium hydroxide. Here what happens? CH3, here C, here CH3, here this one will get bonded to this CH2. Here it becomes 2. Here C double bond O, here CH3. Here one hydrogen from here CH2, here one more hydrogen CH3. We have written one hydrogen in the bonding form, and this hydrogen, it will mix with this. They will share one electron of this hydrogen and one electron of this oxygen. Okay. So here what happens? Let you see. Here earlier, before reaction, there was double bond. Double bonded with this oxygen. Now here, this bond broken and this hydrogen bonded with this oxygen. Clear? And the one electron of this carbon, it is bonded with one electron of this carbon. This is the bond. You can see here. This is the bond. This is the bond. It is the bond between this carbon. This is the bond. Here, this hydrogen and one electron of this oxygen and one electron of this hydrogen gets bonded here. You see this one hydroxyl group. This one hydroxyl group and this one ketone group. So here also two functional group present. That's why it is ketol. This one acetone. This one also acetone. And this one the product formed is diacetone. Alcohol. It is diacetone, no? Here, double acetone is there. The presence of double acetone is there. And together with alcohol. Okay. How aldehydes are easily dehydrated. Similarly, ketones also dehydrated easily either by heating or by treatment with what? Dilute acid to form alpha, beta unsaturated ketones. Let us see the example. For example, here diacetone alcohol. Let us write that one. Okay. Here CH3. Here C. Here OH. Here CH3. Then here CH. Here 2, no? Let us write here one H. Clear? Here C double bond O. Here CH3. Let us check it out. CH3, C, here OH, here CH3, here CH2, C, here H2. This hydrogen, it is in the bonding form. Okay. Here then carbon, double bonded to oxygen. Here single bond, CH3. Now let us see by heating what happens. Here CH3, C, Here CH3. Here this carbon, it is bonded 1 2 bonding, and here it should be double bond, because here this hydrogen and this hydroxide, it will become water. Okay, so here one bonding, this carbon need one more, that's why there will be double bond, and this carbon also need one more bonding, because this bonding broken and this bonding also broken, because hydrogen and hydroxide, it becomes water. So this carbon and this carbon, it will make double bond to each other. CH. Here C double bond O. Here CH3. Okay, now it is known as acetyl oxide. Here let us see. 1 2 3 4. 1 2 3 4. Its IUPAC name will be 4-methyl. This is methyl group. methyl. Methyl. Here it is 1 2 3. Here in the third carbon, that alkene group is there. Alkene. It is double, unsaturated. No. Here this one alpha, this one beta. Alpha unsaturated and beta unsaturated. Okay. So here 1 2 3 methane, ethane, propane, butane, pentane. So it is pentene. PENTEN. Then 1 2 2 on. ONE on. ONE. As it is ketone, that's why all the ketones, its suffix is at last ONE on. Okay. So I hope you have understood aldol condensation thoroughly. So here, if you go through this, then hope in your future, in all sorts of competitive exam, if this question may come, then you can easily deal with this question, and you will become satisfied by yourself after having a face up. So if you are satisfied by my approachings, then please keep watching my channel, Scientific Phenomenal Facts. Thank you.